Okay, kinetics is another topic that we're going to just cover the outline of. Make sure you know what you need to for the final exam. Kinetics has to do all with the rate of a reaction, which is just essentially how fast a reaction happens. Now, a reaction actually happens at the molecular level. What is happening is when two or more, however many are in that specific reaction, when molecules collide, that's when a reaction happens. As long as they collide with sufficient energy, then the reaction will happen. So, what you need to know for kinetics, you need to know that reactions happen when the molecules collide. And so what that means is more reactions equals a faster reaction rate. And you will be expected to know ways to increase the rate of reaction. Okay, so it is very important. More collisions means a faster reaction rate. Now over here I've put 4 ways to increase the rate of a reaction. The first is to increase the temperature. Now remember that increasing the temperature increases the speed of molecules, and if the molecules move faster, then they're going to hit each other more often, so more collisions, faster reaction rate. Another way to increase the rate of the reaction is to decrease the volume of your container. If there's less room for the molecules to move around in, then they will hit each other more often and therefore a faster reaction rate. Another one which you don't have as often, or depending on what type of reaction that you have going on, if you have more reactants available and you can put them into your system, that would just again be more molecules, so more collisions, so a faster reaction rate. And the last is a catalyst. Now a catalyst, what that does is, well, I'll show you graphs in a second. It will decrease the rate of reaction. The important thing to remember is that all a catalyst does is make it move faster. When you get to equilibrium and Le Chatelier's principle, you'll talk more about that, but a catalyst just makes it go faster by decreasing the activation energy. Here are on the next slide here. Here is a graph. Now think quickly because this will be on your final exam if this is an endothermic or exothermic graph and why. You should say that this is exothermic because there would be heat exiting or energy exiting. Now a few things that we need to label here. From the reactants to the top of your hill is always called your activation energy. Now that's written in a few ways. You can just write it as activation energy, that's fine. But one common way to write it is a capital E with a subscript A. That's the amount of energy it takes to make a reaction happen. Now since, and I'm just going to highlight this real quick, since the amount of energy it takes to get to the top of the hill is equal to the amount of energy, is equal to the amount of energy that it takes to get back down to that spot, right here. That is the reason why that activation energy is not included in our delta H value, because our delta H is still our products minus reactants, and so this stuff doesn't really actually matter in our delta H value. Since this is a negative delta H value, it is an exothermic reaction. Now, what we've been talking about, though, is a catalyst. All a catalyst does is lower the activation energy, and I circled all these things lots of times. I know I have a lot of crossing out already on there. But what I want you to notice is that a catalyst, and I'll just use a dotted line, a catalyst does not change the delta H. So if I draw in a catalyst there, it just lowers the activation energy. Notice that the products are still at the same spot, the reactants are still at the same spot, so my delta H remains unchanged. All it did was make the reaction move faster. Alright, you can see the same thing here for an endothermic reaction. Our reactants are products, This time, notice that the activation energy for an endothermic reaction is a lot higher. Our delta H there is, again, our products minus reactants. With the dotted line, I've drawn in a catalyst. Again, notice that our products are the same and our reactants are the same as they were before. Our activation energy is different, but our delta H remains unchanged. So a catalyst does nothing to the reaction except lower the activation energy to make it go faster.